So today we'll be understanding the theoretical part of setting up the Hadoop cluster. So you'll have to understand some few key concepts on top of that. So the next class we'll be seeing the whole practical session itself. Thanks for the acknowledgement. Yeah. So we'll get started with this. So basically need to understand something here. So understanding the Hadoop cluster. So when you say Hadoop cluster, so we have learned something called HDFS and MapReduce. So at least we know what is the key concepts on what HDFS and MapReduce is all about. So when you say HDFS is meant for storing the data, processing the storing the data in terms of distributed data nodes across several data nodes. So that is one thing that is primarily focused on HDFS, and the primary focus of MapReduce is to process or do some computation on top of the data that we already have stored under HDFS. So this is what the primary two focus is on. To set up the Hadoop cluster, you essentially need to go through some few important tasks before actually setting things up. So basically, you need to understand that Hadoop can be set up only on a Linux machine. So primarily, so it is not just only on a Linux machine. You can still set up on a Windows machine. That is an indirect way of actually simulating a Linux environment using Cygwin and doing things up. Absolutely, we never recommend you to actually install Hadoop on Windows, because that is not at all, even for testing purpose, we don't really recommend that. So always stick with Linux machine. So the reason behind we giving you access to cloud servers actually answers that question. So we want you to actually practice on production level scenarios, production levels setup. So just get started with this setup. So Hadoop is primarily meant for commodity machines also. So essentially it is not really tied up with hardware that is all more expensive or specifying only higher slots of configurations. So that is not really required. So even though the bulk of the Hadoop framework, the whole Hadoop framework itself is written in Java. So that is something you need to understand. The whole Hadoop framework itself is written in Java and C++, a mix of both. So in that way, like you can't really, okay, even though Java has an has a feature of you have something called portability, which means like whatever be the operating system it can still run in. So that will not really be fitting for that fact will not really fit well for Hadoop to run on Windows or any other operating system, because this is more specific to the Linux operating system, to Unix based operating system. So that we need to understand, Windows operating systems are primarily not supported for production level scenarios, so we don't even recommend that for testing purpose too. So before getting into that, so you need to understand, okay, we are all talking about clusters, we are all talking about name nodes, data nodes, and etc. So before getting into that, so how large should be a cluster? So there is one common question that we need to ask. So what is the actual cluster size that you need? You will find that as a minimal cluster size. So there is nothing called a minimal cluster size. Basically, you can start with even 4 node cluster or even 10 node cluster or even 3 node cluster based on what is your requirement. So there is no restriction in actually scaling up or scaling down. So that is what the beauty of Hadoop itself. So you don't really need to worry about, okay, this is where when we started up, so now we might actually have to scale up to 50 nodes later. You don't really need to worry about that, because initially you can start with even 3 node cluster and then you can expand it further. So the cluster size always depends on what is your requirement is, and there is nothing called specific cluster size. So based on the cluster size, either if you can increase your cluster size, the whole setup can be actually processed faster. On the other hand, if you actually decrease the cluster size, the whole Hadoop job will actually take so much time than usual. So cluster setup and installation. Basically, there are many ways of actually setting up the cluster. So I'll take you through the most effective and the most straightforward way. So stick with it. Just stick with each and every step. Everything should be working fine. So that is what we will be focusing on. Before getting into this, we expect you to be quite comfortable with Linux. So that is something very strong thing that we focus on. We want you to be at least comfortable with some Linux commands, at least comfortable with command line interface. So executing some commands and getting things ready. So these are all something we need to have. So first and the foremost thing we need to have is you need to have your Java installed. So when you say Java, you need to install JDK. So when you deal with JDK, what do you mean by JDK? JDK is nothing but Java development kit. So that is more relevant here because you need a JDK to be installed here. You will still have few other versions of JDK, that is you have Open JDK or different other versions, but that is not really will be recommended for production scenarios. Always stick with Sun JDK or even Open JDK. Nowadays the later versions of Open JDK are all still performing good in terms of like competing with your Sun JDK, but you can still stick with your standard Oracle JDK. That is previously we call it as Sun JDK, now it is Oracle JDK. So stick with that and make sure you have installed Java. And just to test things out, just execute Java space hyphen version. So that should actually tell you what is the version that you have. Basically, the version of Java that is all required is 1.6 or 1.7 or less. So that is what the requirement is. So creating a Hadoop user. So we have actually decided that okay, Hadoop would be here. So essentially to understand things up in terms of getting your whole Hadoop setup ready. So when you actually see the Hadoop setup, basically any Linux machine or any service that you're going to install on production level scenario, there needs to be actually given a specific user control, that just to make sure that one single user is meant for one single service. Because even though like you are compromising on some user is all being compromised, so they don't really get access to other services. So that is one key feature, that is all more of a Unix standard, that if you are interested you can actually explore that. But basically any when you are actually focusing on Hadoop setup is something that we are going to do, and we want some user to take care of the whole ownership of that setup. So that is what we are going to do. So before getting into that, we need to add a user called Hadoop. So it can be any username, but for brevity's sake I'm making it as Hadoop. Once you do that, you can actually go ahead and download the package from Hadoop. So the version that we are going to use here is version 1.0.1. 1.0.1 version is something that we are actually picking up. So this is more stable in terms of production, and this is something very good, optimized and more stable. A lot of fixes are all made. So that is something we want you to pick things up, because the version we are going to use will be Hadoop 1.0.1. So this is something we need to understand. So the installation directory, so the place at which the installation will happen is where the standard installation directory that we stick is what you call it as slash data. We create a directory called slash data, and we'll be putting all the Hadoop related or ecosystem tools under that slash data. So that is how things will work out. So these are all some standards we actually use, and we actually need to understand something called steps to actually install. So when we actually deal with the steps to install, you actually pick that up. So basically get into slash data, not user local, slash data, and pack download that Hadoop tar file. So essentially the version that we will be using is primarily 1.0.1. So that is a more stable version that is more compatible to Hadoop ecosystem tools too. So then moving forward, you need to actually extract that and give the next permissions. So there is something called SSH configuration. So I believe at this point you all know what SSH is. SSH is your secure shell. So that is primarily meant to connect remote machines together from a remote place. So that is how SSH is all primarily used for. Basically for the same purpose, you need to actually make sure SSH is a primary way of actually to administering from a distributed node. Basically, when we deal with Hadoop, we have something called thousands of nodes or hundreds of nodes. So how does one node, when we say something as a master needs to constantly check the status of your slave nodes, right? How does that do? Unless it is having some permission of your administrative permissions or some kind of good ownership, it will not really be doing that. That cannot be happening over your TCP/IP protocol. So that needs to happen through your SSH, which means your master should log in as that user into that slave node, that is your data node, and understand what is happening inside. So that for that kind of configuration, or even better way of actually distributed processing, where you actually deal with more data nodes, and when you have your master node configuring everything or managing everything, you need to actually understand what SSH is all about. You need to make sure that, so when you deal with that, your master node is going to SSH into your slave node. So that for every time you can't really be before the machine and type in the password. So rather you need to configure something called passwordless authentication. Passwordless authentication is nothing but generating a key for myself. Take an example. If you trust me and you know, okay, I'm Saravanan, and if you actually believe me, and if you are actually, if you authorize me to actually enter into your data center, so which means I have some access ID, right? So that access ID should be actually given to you, so that you program it inside your data center. So whenever this access ID comes in, there will not be any question of actually blocking me. So I'll be directly. So similarly, using SSH configuration is the same process, where I need to generate my own public ID. So that is what we call it as RSA pair. So that is your public key. So public key for every user, which means that I'm a user and I need to generate a public key, and this public key needs to be pasted into content of your authorized keys. There is a file under SSH directory, that is your default SSH directory. There is something called authorized underscore keys. This authorized underscore keys file is primarily that actually store all your public key, that is all authorized, which means my public key should be pasted into the authorized keys of the remote machine, which means of the remote users SSH directory. If that is happening, so I will be, whenever I'm trying to log into that machine, rather than asking me for a password, so it will directly allow me. So that is what you call it as passwordless authentication. So this is quite relevant in set. So to set up a passwordless authentication, you need to generate an RSA key pair for the same user. So here we have three modes of, you primarily have two modes of setup of your Hadoop cluster. One is your pseudo distributed cluster, the other one is your multi-node distributed cluster. So these are all the two primary setup cluster setup available. So one is your pseudo distributed. Pseudo distributed no cluster is nothing but you have 5 components. If I like, we have not discussed the later 3 components, but we primarily focused on name nodes and data nodes. Similarly, there are a few other components called secondary name node. You have something called job tracker. You have something called task tracker. So this is all the extra five three nodes. So essentially there are 5 components that is all on the whole required for the Hadoop cluster to run. So for that to happen, like basically we need to actually deal with something called setting up all those nodes into different machines. In production level scenario, these each and every component should actually sit on different physical boxes, but not necessary. So for the initial setup, for anyone to actually learn things up, just start with your single node distributed cluster. So which means, so your pseudo distributed cluster, that is what we call it, a pseudo distributed cluster, which means it is not really distributed, it is a false distributed cluster, which means you pick up one single machine and inside one single machine itself you install everything. So that is what you call it as pseudo distributed cluster. All the components will be installed inside there. So that is what we will be doing. So initially this session, first setting up a cluster, we will be setting up a pseudo distributed cluster. Later I will be explaining the way to actually expand it into n number of clusters. So let's understand that. So we need to first generate the RSA key pair. So using SSH keygen -t RSA, you a key pair. So once you do that, so this ID underscore RSA pub would be created. So that is what you call it as public key. This public key's content should be pushed into your authorized keys. So these are all some standard files where your SSH will look out. So whenever there is an authentication or whenever there is a incoming connection, so it will be checking the authorized keys. If you are already there, it will not ask for the password. If not, it will ask you for the password. This, in fact, like, people should not really think it is a security hole. In fact, it is a even more stronger security. So because there is nothing, there is no other way you can actually directly access your thing unless you add your public key inside your authorized keys. So there are few configuration options you need to understand. In this configuration, you have some specific things that is more relevant for you to understand here, the configuration files. When you say Hadoop, the setup itself is all quite a bigger process, not so big a process, but essentially you need to understand each and level. So that will make sure you actually get started with each and every step. But don't think that administrator's role would be different and developers role or architect's role will be different, because the whole funda behind Hadoop and the ecosystem is to understand the whole process end to end. Because when you are a developer or an architect, you know what is the logic your MapReduce is going to run. But when you have created the job, so that does not really make a whole completion of your MapReduce job. Basically, you just need to test it out on the right cluster. So before that, you can't really access. There is no standard Hadoop cluster you can actually see, because each and everything differs with your own MapReduce job. There is no kind of optimized or more focused technique that you can actually see. So that is what we need to understand here. The Hadoop configuration available here, there are a few configuration files you need to understand. So one is Hadoop env.sh. So Hadoop env.sh will contain all your environment variables, so that actually contains your environment variables for the Hadoop setup. The later part, you have something called core site.xml. Core site.xml will contain all your Hadoop core configuration options. So that means how your HDFS, what is your HDFS, what is the port number, and what are all the key things that we need to actually change. And the other part is what we call it as HDFS site. So when you deal with HDFS site.xml, you have something called the configuration option. So the configuration option for HDFS site would actually contain all your HDFS specific parameters. Take an example, we have already seen something called replication factor. Replication factor is something that needs to deal with your HDFS data. So which means your HDFS site.xml, that is a configuration file where you can specify your replication factor. That is all more relevant to your HDFS service. And on the other hand, you have something called mapred site.xml. Mapred site.xml will have more of configuration that is all more specific to your MapReduce task. You can increase IO split dot MB size. You can actually increase the number of tasks per node. So you can increase the number of mappers, number of you can say what is the maximum number of mappers, maximum number of reducers, and so on. You also have something called masters file. Masters file is quite relevant in terms of understanding things in as a secondary name node. So there is a file called master. You need to actually understand that this file, the name of this file is quite misleading, because you have a master called name node. The name node is a master of the Hadoop cluster, but there is a file called masters. I just mentioned something called secondary name node. Since name node is a very critical component in any Hadoop cluster, you need to have a backup node for a name node that is storing the metadata information. So that is what we call it a secondary name node. The secondary name node, the number of you can actually store your secondary name node information under your masters file. Similarly, your slaves file, what you will be storing, you will be storing all your data nodes URL, or that is your data nodes host name or your IP address. So that is what your slaves will be containing line by line. So this is something you need to understand on a bigger picture. So these are all the primary configuration files you need to understand. Let's move forward. So Hadoop does not have a single global location of for configuration information. So this is something that might people actually feel it as okay, why not centralized? So you can have, there is a lot of advantage being non-centralized, because when you deal with Hadoop, you actually deal with a lot of different hardware components. So since it actually also accepts commodity grade machines, sometimes you might deal with 16 GB RAM machine, you might also deal with 2 GB RAM machine, you might also deal with 4 GB RAM machine, you might also deal with 8 GB RAM machine. So basically you can't really specify a common setting. So you can't really specify a common configuration option. Basically when you say configuration to be generic, it is not optimized. Agree with my point? So that is what the funda here is. So when you say your configuration is common, it is not really optimized for sure. So that is the reason why each and every machine, each and every data node that we might actually add in might actually differ in the hardware capacity or the capacity at which that it can run it. So basically, if you for a 2 GB RAM machine, you can actually say this number of mappers can be reduced. While in case of 16 GB RAM machine, because since every machine has an individual configuration, I can still change it up. So this is something we need to understand. So seems to be a complex task, but when you actually move forward, that should be very smooth. You have few other components to actually ease out the whole process of configuration management called configuration management tools. You would have heard about Puppet or Chef to actually handle that. So these are all something that you can actually make a note of. Otherwise, that is all out of we are deviating too much. So that is what the whole funda is. So you don't have a single configuration file for the whole Hadoop cluster. Each and every component has its own configuration. So this is what the funda here is. So basically, Hadoop is designed to actually have a single set of configuration. So once you have one single set of configuration ready, you can just copy the same single set of configuration across all your data nodes, and it will still work with very minimal changes. So this is something, the advantage of being more simple, the simplicity factor. There is something called control scripts you need to understand. When you deal with control scripts are the actual scripts that will actually tell you what are the how to actually control the whole Hadoop cluster itself. So that is what the funda here is. So when you deal with control scripts, so these control scripts are primarily focused on something that will actually control the whole Hadoop cluster, like starting the cluster, stopping the cluster, restarting the cluster, rolling restart, doing some high level administrative tasks. So that is what we call it as a control script. So these control scripts are available under your bin directory of your Hadoop installation. There are another two files that we just mentioned. So there is something called masters and slaves file. Masters files is quite misleading because masters does not contain your actual master content, while your masters file will contain your secondary name node, host names or IP addresses. So similarly, your slaves file something called the actual data nodes entry. So when you say data node also has some other component called task tracker within the data node itself. So that is what you call it as. So in master node scenario, so based on the size of the cluster, so you also need to understand that even though we have seen five components, so the five components is not like we can actually, but anyway we are going to see the initial setup of pseudo distributed cluster where we set up everything inside one single component itself, one single machine itself, and get that Hadoop up and running. That does not mean like you can actually you in production level scenarios, that does not mean like that is what will be used. In production level scenarios, each and every component will reside inside different physical boxes. But when you see that, okay, if your cluster size is not more than 8 or 10, so you can still stick with something called the master node, which means one node you can actually consider it as a master, where you all can have the name node, the secondary name node, and job tracker itself. But that is not really recommended. But still, for testing purpose, that is all fine, because there is no point in having the secondary name node also in the same machine, because the purpose of secondary name node to reside itself is to handle in case of failures. So if you actually consolidate everything into one single machine, that will not really help you out on the production scenarios. But for testing purpose, that is not really restricted that each and every machine every component should be in different physical boxes. You can still work out on this plan. So that is what we need to understand. And on the other hand, we need to actually understand that what are all the different configuration properties and what are all the different XML files. So this is what we need to understand here. So let's see what are all the different files. And once we have actually configured or updated all your XML files, you can actually go ahead with the process of formatting your name node. Basically, when you say name node is responsible for your HDFS indexing. So the whole process of maintaining the file system and the metadata information about the file system should actually happen through this process. First, you need to actually format any file system. Even though you buy a hard disk, like that might not really be formatted, most of that previously available. So which means you'll have to format it first to make use of it. But see, similar cases what you have it in HDFS. So before actually getting your HDFS up and running, you need to actually format your HDFS. So that is what we are actually doing here. You have something called name node, and this name node, and you can give a parameter called format. It will format the name node structure, so which will create the necessary file system table or similar metadata information to actually get your whole data up and running. So that is what the funda here is. We'll just finish off the session by exploring the XML data and the entries available. So we'll actually update that data inside your product. Yes. Yeah, please go ahead. Yes, Harish.
Hi, Sarna. The question I have is like, so I think you already told once you set up all the things, the very first step is name node format, right?
Okay.
So to run this command, before this, do we need to start the cluster? Do we need to start services for Hadoop? No.
Essentially, yes. Before running that command, you need to actually start the services. Before even starting the services, you need to actually format the name node. So name node formatting should not really happen after starting the service. Before starting the service, you need to actually format the name node.
Okay,
Because
so
name
so
node
so my
formatting
question,
is,
okay,
yeah, go
it,
ahead,
it
go
it
ahead.
is not dependent on formatting is not dependent on any service or any process
We need to
which is
understand one
running
thing,
running.
formatting will happen once in a blue moon day, because formatting only the first time, not later, unless
Right, right.
otherwise really required. So in that
Agree.
sense, before even starting the service, you need to actually format that. You need to get the file system ready. Only then the file. Otherwise, when you try to start it, it will throw an error during the startup process that name node has some inconsistent state. You don't have anything formatted inside. So that way, like you will have to redo the same process for format that and
Oh,
then restart the service.
oh. So I have other question actually.
Yeah, go
So
ahead.
you showed you showed some of the configuration files, right? Like
Yeah.
MapReduce site and HDFS site and so. What is the
Yes.
hierarchical order in in these configuration files? I mean, like
There's nothing
when you
called
say
hierarchical
site
order.
means okay,
There is nothing called hierarchical order, because everyone has its own, like there is nothing called one behind other fellow, because everything is all separated, so it's all on the same level. Essentially one configuration file takes care of your core configurations, which means like your name node, your HDFS and things. And there is another configuration that is all more focused for your HDFS specific configurations. And there is another file called mapred site.xml. That is nothing but your more specific MapReduce or your tasks specific configurations. So that is what the configurations are all split across. Otherwise, like there is nothing called okay, this fellow is behind that configuration. There is nothing called hierarchy here. Everything will be taken on one single shot.
Oh, so I'm sorry, but I'm asking questions. But
Yeah. No, please go ahead.
question to the one which you just now said, right? So if that is the case, then we have a MapReduce site XML, then we have a HDFS, right? So MapReduce is running on the HDFS framework. So let us say the cluster is online, and I'm doing a
MapReduce
MapReduce
does
job,
not run
and
on
suddenly
HDFS
I
framework.
okay,
MapReduce is a
okay,
different component that is primarily meant for processing the data. HDFS is a
okay,
different component that is primarily meant for storing the data. So
agree,
there is nothing like MapReduce makes use of HDFS. That does not mean like MapReduce runs on top of HDFS. MapReduce is a component of
ag-
your Hadoop cluster, Hadoop framework. That's it.
agree, agree. So
Yeah,
MapReduce might be different from HDFS,
yeah,
uses or processes the file which is stored in a HDFS format, and
yeah.
then the logic takes over and processes and outputs whatever is required, right? So given a scenario like, okay, I have a MapReduce job which I'm trying to optimize, and I went back to MapReduce site.xml or any other MapReduce environment configuration file, and I made the change. Can I make the
Okay.
change online, or do I need to basically, or will that change become online effective right after I save the file, or do I
No,
need to come back and shut down any other Hadoop service or HDFS service?
nothing would be
How does it
instant
work?
so because you will have to restart because that will not really work out, right? So it is not something a smaller service. You are actually dealing with a very serious enterprise level Hadoop frameworks. So which means like it
Agree.
does not really make sense like when you save a file that will be taken up. So you'll have to do a restart because as we clearly know Hadoop is meant for offline processing. So that needs to have some kind of structured querying. So some
Sure,
structured way of actually getting things. And if you are actually changing some configuration, that will not be taken into effect right away. So you'll have to, because
sure.
when you say the job conf will actually build the configuration only during the startup, you'll have to stop and
So
start the
so
service again.
so even if I touch MapReduce, do I still need to come back and restart the HDFS also? That's my question.
Yes, essentially no, but if you have actually changed things up, you also have something called these different components can be started individually or stopped individually, or also can be started as a whole. But the most recommended format is to stop on the whole based on the hierarchy. So you have something like even though like everything is a different component, the configurations remains the same, but the services has its own hierarchy. So which means like before actually starting
Exactly.
name node, you can't really start the task tracker. So similarly, like before even starting job tracker, your task
Exactly.
tracker cannot run. There are few hierarchy that we need to actually focus on. So rather than you doing it manually, there is already a control script that does it. So I would recommend, I'll teach you through that way.
Sure. So could you
Yeah.
let us know what is the hierarchy services layer?
Yeah, basically we have not covered up the three more components, but essentially for now you need to actually have your HDFS running first. Then you need to have your
Okay.
name node running first. Then you need to have your secondary name node. Then you need to have your job tracker. Then you need to have your task tracker. So there is another session that we actually explain this in detail. For now, this should actually answer your question.
There's another question from.
Yeah. Yeah. Any other questions, Sri Koneru?
Yeah, yeah.
Go ahead.
My question is, are you configuring a Hadoop cluster on a local disk, or it can be configured on SAN too?
That doesn't really matter because SAN is not something. Just forget about the details on SAN. Essentially, everything
Okay.
can be configured. So because when you say like SAN or your local, that does not really matter much because I consider that as a Linux machine. So when you actually consider that as that way, like internally it might be represented as a different level. You can still configure on a SAN or NFS or any other way. End of the day, when I have the abstracted picture that I deal with a local file system, that should be fine. But you need to understand something
So
like it's not really required. It is not really recommended because the reason behind we going for Hadoop and the HDFS itself is it actually has its own way of distributing the data and distributing the whole managing the whole techniques of optimizing the remote data and getting the data. So again, when you actually add another level of latency through SAN and you are abstracting that as a local disk, which might not really help you out on a longer run on performance.
okay, but well, if that's the case, if it is a local disk, what are you formatting there?
We are going to format the file system, not your,
The
yeah, right. So basically you are going to not format your Linux file system.
Sarvanan, can you hear me?
Yeah, I believe there
Uh,
is a lot of noise from some of your side. I'm going to mute things before you can question the next one.
okay. Can you hear me?
No, no, wait. Fine. So to answer your question, so your question was primarily something that we just saw. Yeah, Edward, I'll just make a note of that. I'll just type in just a moment. So, Kunal, your question was like when you like what if you want to actually install it on a SAN or SAN backed up instance. So that is what the thing, right? Can you speak
hey,
out, Kunal?
uh,
Yeah,
uh,
go ahead. Go ahead with your
my
question.
my thing is when you are under the bin folder, right?
Okay. Okay.
The so when you don't you think when you are formatting the bin consists of so many files, which is related to the operating system.
Let me stop you at this point. So basically, do not go with the assumptions. When we say name node format, you need to understand something called name node is something that is going to be responsible for your HDFS. We are going to format your HDFS file system. We have
Oh,
clearly
okay.
seen that HDFS is a file system, right? To make it usable, you need to format it. So that is what you call it as name node format. Clear, straightforward.
So you physically create a file system for HDFS, right?
Yes, yes, yes.
Okay, you're
You
not
don't
gonna
even need to
touch
deal with
any
any
of the.
specific.
Okay, go ahead.
It will sit in the Linux machine itself. Yeah, fine. And yet,
Sir,
the last two services are all like I just said something called name node. Your you name node. You have something called secondary name node. You have something called node task tracker, and you have something. Sorry, like job tracker should come before task tracker, and then you have something called we'll be explaining this in detail, but for now just understand these are all the different components. Yeah. Any other questions? Krish, you got any question?
yeah, Sarvanan, can you hear me?
Yeah, I can hear you, but there is heavy noise from your side. Basically, any earphones you carry.
Okay, I'll type.
Go ahead anyhow, like fine, you can actually go ahead with that.
Yeah, just want to understand, is HDFS is mandatory for Hadoop? or there are some other file system like Cassandra and all, how they are fit into this Hadoop?
Don't get confused about things because we don't really recommend. Uh, this is totally irrelevant because Cassandra is totally irrelevant from your HDFS here, at least at this point. Don't get confused about few things that you might actually see in the forums, but basically we want to make sure that each and every step that you actually follow is all like more enterprise level. Cassandra has its own place. It has nothing to do with HDFS at this point. Cassandra is a NoSQL data store where you can actually store the data and retrieve the data on the fly. So that is a NoSQL class of thing. While Hadoop is something the framework. So that really does not really make a lot of sense to actually question that Hadoop HDFS is required for Hadoop because without HDFS Hadoop will not really even survive because the core heart of Hadoop itself is HDFS. That is what we focused on. So these are all not a replaceable component. These are all the core components to that makes the Hadoop framework itself. Yeah, fine. Yes. Any other questions? Of what are all the configuration files. So your configuration files look like this. So you have something called code.xml, the configuration file. This is a minimal configuration file you might actually. So you have the configuration as XML data. So the parser to work out. So you have something called property, the name and the descript, the value. So the value here is the Hadoop temp directory. This is a directory that you will be using for HDFS. You will be specifying a directory inside a Linux file system and making that Linux file system directory format it based on your requirement. And similarly, you have some other property that actually specifies what is your HDFS your service. So where it want to run and what is the default port. These are all something available. Similarly, right, you can actually specify something called DFS replication, the replication value. And then here in MapReduce size, you have something called MapReduce site, you have something called MapReduce specific configuration options. So we'll be actually seeing this in the next class on setting up the whole Hadoop cluster itself. So we have got a lot of things to actually explore. Fine for now. Any other questions? Let me know. Edward, you got the answer? Yeah, perfect. So it actually starts this way. The actual HDFS, then your that is your name node, then your data node, then your secondary name node, then your job tracker, and finally your task tracker. So basically, we don't really need to deal with this kind of serialized starting and stopping. So that is the reason why you have a control script that actually starts every script in one shot. Basically, the internal script itself will take care of the dependency that first this thing should start, later only this thing should start. But anyhow, that really makes a lot of sense to understand this on the dependency layer. Fine, then we'll actually catch up on the next class. Thank you.